Welcome to Solving Trigonometric Equations, Part 1. So we're going to use our all stations to crook all, and we're going to apply different concepts to solving trig equations. So the first ones are we're going to be given one of our trig ratios and a bit of other information, and then we have to use that to find which quadrant it lies in and then solve for whatever the trig function at the end is. So for our first one, we've been given that sine theta is equal to 4/5 and cos theta is less than 0. So sine's positive and cos is negative. So that means that the triangle is drawn in the second quadrant. So you put theta in the corner and you put the 4 and the 5, because it's sine theta, on the opposite and hypotenuse. Using Pythagoras, we then find the other length. So the other length, using 5 squared minus 4 squared and take the square root, the other length is 3. So finding the value of tan theta, which is opposite over adjacent, that gets us 4/3, but tan in that quadrant is negative, so it's negative 4/3. With the second one, we've got tan theta is equal to negative 3/5 and cos is greater than 0, so cos is positive. So we've got tan is negative and cos is positive. So therefore we draw the triangle in the fourth quadrant. Labelling the triangle, because tan was equal to 3/5, so that's opposite over adjacent, so 3 on the opposite side, 5 on the adjacent. Using Pythagoras allows us to find the length of the hypotenuse, so 5 squared plus 3 squared, the square root of that gives us a square root of 34, and sine in that quadrant is negative. So sine theta equals to opposite over hypotenuse, so that's 3 over the square root of 34 with the negative in front. For our second set of examples, we're finding all the solutions between 0 and 360 for when sine theta equals to 1/2. Now we know that sine is positive in the A quadrant and the S quadrant. So that means that sine is positive in the first and the second quadrant. So you draw your triangles in these two quadrants, you calculate theta, and you place that value in the triangles. So to find theta, we do sine minus 1/2. Theta equals to 30 degrees. So put your 30 degrees into the triangles, and remember that it is the angle that's created from the positive x-axis. So the first angle is 30 degrees, and around to the second triangle, that's 180 minus 30, or 150 degrees. Thank you.